So our u would be the x cubed 9x squared plus 3x. That makes du dx the derivative of that, which would be what? Yeah. Yeah. And then from there, we can divide the 3x squared under the du and times the dx up. So we'll have du over 3x squared plus 18x plus 3 equals dx. And then remember, our goal is to take that. This will become our u. And this will become our du over the 3x squared stuff. So we have x squared plus 6x plus 1 over u du over 3x squared plus 18x plus 3. Now remember, in this step for u sub to work, the x parts have to cross out. But what could I take out of the bottom x part so that they do cross out? Take a 3 out. Very good. So that would make this an x squared plus 6x plus 1. Which would then allow me to cross out the top and the bottom. So then we'd have the integral of, my 3 is going to pull to the front. Keep in mind it would be a 1/3. And then my u is also on the bottom, so that'd be a 1 over u du. And then remember, 1 over u is a special. What's the antiderivative? So it'd be 1/3 ln u plus c. And then you would just basically take your u stuff, snap it back into the u spot, and you're done. So it'd be 1/3 ln absolute value x cubed plus 9x squared plus 3x plus c. Okay. So if the denominator, that's the bottom power, is greater than the top, okay, that's how you would do it. Exactly how you already know how. Okay, the problem is, take a look down at number 1. Okay, if the top is bigger than the bottom, you're going to do polynomial long division. Okay, which you should have learned this in Algebra 2 and again in pre-cal. But basically, long division is where you take this, so 2x cubed plus 9x squared plus 3x plus 7. And you're going to divide it by the 2x plus 3. Okay, so in case you forgot how to do it, you would think, what would I times this 2x by to perfectly match the 2x cubed? What would I need to multiply with? X squared. Good. So then I'm going to take the x squared. I'm going to times it by both of these and then line it up under the first 2 terms. So x squared times 2x is a 2x cubed. And then x squared times the 3 is a 3x squared. Okay, then in long division, after you multiply those, you're supposed to subtract. But remember, you want to subtract across that whole row. And then my 2 minus 2, remember, I kind of rigged those so that they'd cross out. So the 2 minus 2 is gone. Now I have a 9 minus 3. That would be a 6x squared. Carry down the next term plus 3x. And then you repeat the process. So you would say, okay, now I have a 2x. I need it to perfectly match a 6x squared. So what would I need to multiply on top? 2x times 3x. 3x times 2x is my 6x squared. Remember, I wanted those to match. And then 3x times 3 gives me a 9x. Then remember, you're subtracting that whole row. So the 6 minus 6 crosses out. 9 minus 3 is plus 7. And then we just have to do it one more time. So I have a 2x in front. I need it to perfectly match a negative 6x here. So what would we need to multiply the 2x in the front by to match the minus 6x? -3, good. -3 times 2x is a -6x. -3 times 3 is a -9. But then remember, when you're minusing on minuses, they're going to switch to pluses. So this is now a +6x and a +9. -6 and +6 cross out. 7 + 9 is, and that's called your remainder. Okay, so then what you should have done is after you do the long division, you're going to rewrite your integral as what you got for your quotient. So it's x squared plus 3x minus 3 plus a remainder of 16 over 2x plus 3. Okay, so this should be the answer that you got when you divided it. And then you're going to add the remainder over the divisor. So it's what was left over what you divided by. Okay, then remember, I can integrate this all together, or I can do it as two separate integrals. So we're going to let these each be their own integral, and here's why. For the first one, I can just regular power rule. So x squared plus 3x minus 3, that's regular rules. What will the antiderivative be there? So 1/3 x cubed plus 3x. And I'm going to save the plus c for the very end because this piece is going to need u substitution. Okay, so let's work our u substitution. What are we going to choose as our u? Remember, you're just looking at that piece. X plus 3. And if my u is a 2x plus 3, my du dx is just a 2. Then remember, all times the dx up, divide the 2 down. So it'd be du over 2 will replace dx. So this is now going to be the integral of 16 over u du over 2. So the 2x plus 3 turns back into a u, your dx turns into a du over 2. Then divide the numbers. That'll be an 8 times 1 over u. Okay, remember that's the same as 8 over u. The only reason I'm separating it is because 1 over u is a special. It goes back to what? So it'd be 8 ln u plus c. And then in the last step, I'm just going to bring all of this stuff down to be part of my final answer. So my final answer would be 1/3 x cubed 3/2 x squared minus 3x plus 8 ln absolute value 2x plus 3 plus c. But you would only need this method if the top polynomial is bigger than the bottom polynomial. Make sense? All right. Let's do one more without endpoints. Go ahead and go to the next one. So first thing I notice is that the top power is bigger than the bottom. Okay, for a bottom, if I'm doing an antiderivative, I'm going to have to do long division. So let's work that out over here to the side. It's going to be x squared plus 2x divided into 2x cubed plus 8x squared plus 10x plus 2. Then you would ask yourself, what would I times my x squared by to perfectly match a 2x cubed? A 2x, very good. Then remember, I'm going to take the 2x and multiply it by both of these things on the outside. So 2x times x is a 2x cubed. 2x times 2x is a 4x squared. And then we're minusing all the way across. First two should always cross out, because remember, you picked what was on the top to make them cross out. 8 minus 4 is going to give you a 4x squared. Carry down the plus 10x. What will my next multiplier be on top for my x squared to turn into a 4x squared? Just a 4. 4 times x squared is 4x squared. 4 times 2x becomes an 8x. But then remember, you're subtracting that whole row. So minus, minus. What's going to be left over from the 10x minus 8x? 2x plus 2. Now, at this point, if I asked you the same question, what would I times x squared by to turn it into a 2x? No way for you to do that. So this is your remainder. So as soon as you can't multiply this to match this anymore, that's when you've identified your remainder. So let's rewrite our integral. When we divided it, we got 2x plus 4. And then the remainder was a 2x plus 2 over an x squared plus 2x. Remember, technically, that's all one big expression, but we're going to split it up into 2 integrals because we see that the first one will not need any special method versus the second one. So 2x plus 4, I'm just going to skip all the way down to the bottom. What's the antiderivative of that? X will go to an x squared, then divide the 2 on the 2, it's gone. 4 will go to a 4x. And then for this part, I'm going to need u sub. What will my u be? X squared plus 2x. Then my du dx is a 2x plus 2. And then remember, my dx will come up, my 2x plus 2 will go down. So du over 2x plus 2 needs to replace the dx. So it's going to be 2x plus 2 on top over a u, du over 2x plus 2. And then we can see at this step, the 2x plus 2s are supposed to cross out and they will. So that means they're gone. Okay, am I just left with a u? Technically, it's a 1 over u, which brings me back to my ln u. And then for my final answer, I'll just put the x stuff back. So it'd be ln absolute value x squared plus 2x plus c. Pretty much. Okay, so number 3 is kind of similar. So let's just skip to number 4 where we have endpoints. Okay, so skip ahead to number 4. Okay, go ahead and set up your division. And then one thing that I haven't mentioned that you should have learned when you initially did this in Algebra 2 is if you ever have a power that gets skipped, you should write that power in. Otherwise, your long division can end up like not lined up correctly. So what I mean by that is that this goes from an x4 to an x2. The power that's missing is an x3. So you should do like this, 0x3 plus 12x squared plus 2x plus 18. Okay, that way, as you're doing your long division, things stay lined up correctly. Okay, then I have a 2x squared plus 6. So I'm going to make it 2x squared plus 0x plus 6. So any of those missing digits for the powers, you would just write those in as zeros. All right, first one, 2x squared. I need it to match a 2x to the 4th. X squared. X squared times 2x is a 2x to the 4. X squared times 0x is a 0x cubed. And then x squared times 6 is a 6x squared. minus all the way across. So these guys are gone. 12 minus 6 gives me 6x squared. And now notice that because I have 3 terms in what I'm dividing by, I'm going to carry down the next 2 terms. Because remember, we want to keep stuff lined up. So my 2x is going to drop down and my 18. What would I times 2x squared by to get a 6x squared? 3. 3 times 2x squared is a 6x squared. 3 times 0x is a 0x. 3 times 6 is an 18. And then we're going to subtract here. Oops, not there, sorry. Minus, minus, minus. 6x squared minus 6x squared is going to cross out. 18 minus 18 is going to cross out. What's going to be the only thing left? 2x. Very good. So let's rewrite our integral. I have my answer, x squared plus 3. And then I have my remainder over my dividend, which is a 2x over, and then the 2x squared plus 6. And then remember, I'm essentially going to just integrate both of those pieces on their own. Okay, at this point, I'm going to put the endpoints back. So we're going 0 to 3 and 0 to 3. But again, you're doing them as separate integrals because this one's regular, this one's u sub. Antiderivative of x squared plus 3, what would it be? Yes. Remember, plus c is not needed when you have endpoints. Then we're going to plug in 3, plug in 0, and subtract. Now, for the 0, we just know it's going to be 0. But for the 3, I'd have a third of 3 cubed. So 3 times 3 is 9, times 3 is 27. But then divide it by 3 again, it's back to a 9. Plus 3 times 3 is 9 again, gives me 18. And then 18 minus 0 is 18 for the first integral. Okay, then for your second one, this is the one that needs u sub. So my u is going to be 2x squared plus 6. What does that make my du dx? And then the 6 goes away because it's just a constant. Then your dx goes up, your du goes over a 4x. So my integral is going to be, separate this here. So it was a 2x on top, a u on bottom, and then a du over 4x. So the x's are going to just straight up cross out, but the 2 over 4 is going to give me a what? So a 1/2 1 over u du. What is the antiderivative of a 1/2 1 over u? 1/2 ln u. And then remember, you have 2 choices. You can bring this back and put the 2x squared plus 6 in, or you could just adjust your endpoints by plugging them into the u. So I'm going to do the endpoint thing because I like that better. So my top endpoint was a 3. So I'm going to write here, plug original endpoints into u equals 2x squared plus 6. So if I do 0 first, just because that's easy, 2 times 0 squared would be 0, plus 6 is 6. My bottom endpoint is a 6. My top was a 3. 3 squared is 9, times 2 is 18. 18 plus 6 is 24. Then when I plug those in on top, I'm going to have a 1/2 ln 24. and a half ln 6 on bottom. And then remember, once you have those two values, you're supposed to subtract. If I notice though, that they both have a 1/2, remember you can pull that out. So I'd have a half ln 24 minus a half ln 6. Pull the half out would be ln 24 minus ln 6. And then do you remember the special rule with that? You can divide them. So 24 divided by 6 would go to half ln. So your final answer, or I'll put your total, is going to be 18 plus half ln 4. No C, because remember you had endpoints. So if you don't have endpoints, you have to put a C. If you do have endpoints, no C. Okay, kind of makes sense. Okay. Go ahead and turn the page. Okay, so thing number 1 is the hardest. The other two are really not so bad. So these are rules off of your anti-derivatives sheet. Let me see if I still have one somewhere. But it's this one that has all the rules on it. So we're doing the anti-derivative. It's rule number 18. Okay, so if you'll write it down, it's the integral of 1 over a squared minus u squared. 1 over a squared minus u squared du. And then the answer for it, let me put it back up here, is sine -1 u over a plus c. Sine -1 u over a plus c. Okay, and so because it's a rule, you're really just using the property. So like, let's say I'm doing number 1. Okay, what is in my a squared spot? Oh, I forgot the square root on the bottom, sorry. Make sure that you have a square root here. Okay, so what's in the a squared spot? 49. If a squared is 49, then what's just regular a? Which is? So if a squared is 49, then regular a is 7. Okay, then we're going to pick what our u is. If u squared is x squared, then u would just be x. Then du dx would just be a 1. Then I can multiply my dx up, divide my 1 down, and my dx is going to be replaced by a du over 1. Okay, so let's go to our little integral here. So it's going to be the integral of 1 over square root. Okay, my 49 is really just a 7 squared minus x squared. Du is over 1, and then I'm just using the rule from there. Okay, that it's going to be inverse sine my u, which in this case is just a regular x, over my a, which we said is a 7. So x over 7, and then plus c. Now notice that because my derivative was just a 1, I didn't end up like pulling any extra numbers out. That'll happen in the next example, but not that one. Okay, so let's look at the second one. Okay, what is my a gonna be? 5. Okay, because a squared is a 25, then regular a would be a regular 5. What is my u? It'd be the 2x because it's what's being squared, right? So my u is a 2x. What does that make my du dx? Just a 2, which means that my du over 2 is going to replace my dx. And then we're ready to do our rule. So my 3 is chilling on top. I have a square root of, I'm going to rewrite my 25 as a 5 squared minus u squared. And then my dx is being replaced by a du over 2. And then remember from here, you can pull regular numbers out to the front. So this is really like a 3/2, and then my special rule, like that. And then for this one, I would use rule number 18. So it'd be inverse sine u over 5. But in this case, my u is a what? 2x over 5 plus c, and then my 3/2 would just kind of stay in the front. Okay, one more like that. Your a is what? Just a 1. Because if a squared is 1, then regular a is also 1. What would my u be if u squared is 16x squared? You have to square root this for regular x. Very good. So my u would have to be 4x. That means my du dx is just a 4. Then times your dx up, divide your 4 down. So let's rewrite our integral. It's going to be an 8 on top, 1 squared minus u squared. And my dx is going to be a du over 4. And then the 8 and the 4, I can go ahead and divide those. So 8 divided by 4 gives me 2. And then this is now my little special rule that I can use formula 18 on. So remember, it goes to inverse sine u over a. My u is a 4x over my a is a 1 plus c. And then just keep the 2 in front. Now, I guess technically putting the over 1 is kind of stupid, but it's not wrong to put it, but you don't have to put it. Make sense? Okay. We have 2 that have endpoints, and we're only going to do one of them. So let's do 5. Okay, go ahead and set it up for me. So pick your A, pick your U. What will my A be? 10. My U will need to be the square root of 25x squared, which will just be a 5x. That makes the derivative of 5 times the dx up, divide the 5 down. So now we're ready to rewrite our integral. So I have a 20 on top over a square root 10 squared minus u squared. And then notice this time the dx is kind of pushed into the top. That's the same. It looks a little different, but a dx over here and a dx in the fraction is the same thing. So I'm going to replace my dx with a du over 5, which means what happens to my 20? Becomes a 4. And then this is now my special. And then I could inverse sine that. So it'd be, put it in brackets because we have endpoints this time. 4 inverse sine. And then it's u over a. So my u was a 5x over a was a 10. Technically, remember there is a plus c, but you don't have to put it down. Okay, now because I went all the way back to x, I'm going to use the original endpoints that they gave me. Is there any simplifying that I could do in here before I plug my endpoints in with this? Yeah, that's really just an x over 2. Okay, my top endpoint was a root 3. My bottom endpoint was a root 2. Hey, what's up? No, that's okay. You're fine. I mean, technically, I haven't counted your absences, but if you just count your time spent in test corrections, you can work off however many absences you have. And you've done test corrections before, right? Okay, and then if you help, there, we can count that too. So you'll be fine.
Okay.
No stress.
Okay.
No stress.
Thank you.
Okay, so we're taking our root 3 and plugging it in. So I have 4 inverse sine root 3 over 2. And then this one is going to be 4 inverse sine root 2 over 2. Okay, then if you don't remember how inverse sine works, basically all that you're doing is sine and inverse sine are the same x and y's, but they're reversed. So instead of for regular sine, I give you the angle, you tell me the number. For inverse sine, I'm going to tell you the number, you're going to tell me the angle.
Oh.
So if I want my sine to be root 3 over 2 with hand trig, I want 3 fingers on the bottom, then I know I would need to fold this one. Does that make sense? So this is 0, pi 6, pi fourths, pi thirds would be my answer. Times it by 4, and it would be 4 pi thirds. Okay, then for the bottom, I want my sine to be root 2 over 2. We're going to find the angle that would make that happen. So remember, for sine, those are my bottom fingers. Then I would want these two. I'd be folding this one, which would be 0, pi 6, pi fourths. And then it'd be 4 pi fourths, which is really just pi. And then remember, it's top minus bottom. So for my final answer, it would be 4 pi thirds minus a full pi. And then remember, you can take your pi and make it a unit fraction. So if I want to take away 1 full pi in thirds, that'd be 3 pi thirds. 4 pi thirds, take away 3 pi thirds is pi thirds. Make sense? Yes.
Why did you say the endpoint not?
That's a great question. It's because when I wrote my antiderivative, I switched back to x.
Okay.
So if I had left this as a u over 10, then I would change the endpoint. Yeah. But if you go back to an x in your antiderivative, you want to use your original x endpoints. Okay. Last one, rule number 19. Go ahead and write it down. Okay, so it's integral 1 over a squared plus u squared this time. 1 over a squared plus u squared this time. And it's 1 over a inverse tan u over a plus c. So looking at the first one, notice the square root's missing and it's a plus, but it's kind of the same bag. So my a would be what if a squared is a 64? Close, it'd be 8. And then my u would just be a regular x, which means my du dx is a 1, which means my du over 1 is going to replace that dx. Du over 1 is going to replace dx. Okay, let's rewrite our integral. 1 over 64 is going to turn into an 8 squared. X squared is going to turn into a u squared. My du is over 1. And remember, if this is an over 1, then you know it's not going to really change anything. We can go straight to our formula. Notice this one is still an inverse tan u over a. So my a in this case is an 8, so it'd be x over 8. But this one also has a little fraction in the front with a 1 over a. So if my a was an 8, I'd put a 1 over 8 in front of that. All right, let's try the next one. What's my a? 2. What's my u? 3x. That makes my du dx just a regular 3. My dx goes up, my du's over 3. And then we're ready to sub it. So it'll be integral 6 on top, 2 squared plus u squared. And then my dx is now a du over 3. And then remember, you can divide the 6 on top with the 3 on bottom. 6 divided by 3 is. So this is really 2 times 1 over 2 squared plus u squared du. And then from there you would say, oh, this is my inverse tan rule. So it'll be inverse tan u over a. Inverse tan u over a. My u is a 3x, my a is a 2. And then don't forget that this one also has the 1 over a in front of that, which means I'm going to have a 1/2. Am I forgetting anything? Yeah, don't forget that really I had that extra 2 pulled out. So what's going to happen with the 1/2 and the 2? Those are basically going to cross out. So you'll just have inverse tan 3x over 2 plus c. Okay, one more left like that. What's my a going to be? 5. My u, I'll have to square root the 49x squared will turn into a 7x. That means my du dx is just a regular 7. And my du is over 7 to replace dx. So I'll keep my 3 on top. 25 will go to a 5 squared plus u squared du over 7. And then remember, if the 3 and the 7 could divide, do it. But if they won't, just leave it as kind of like a fraction in the front. So this is really a 3 over 7, 1 over a squared plus u squared. And then that's where you can use your inverse tan rule. So it'd be inverse tan u over a. U is a 7x over a 5 for the a, plus c. Then remember that the tan rule has a 1 over a in front, which is a 1/5. And then what do I also have even in front of that? The 3 over 7 that was pulled out. And then remember fractions, you times the tops times the bottoms. So 3 times 1 is a 3, 7 times 5 is a 35. And that would be your answer. Okay. The last thing we are going to add to our tan is complete the square. Okay. So when you were in algebra 2, this is like all of the nightmares of things you randomly learned and never used coming back. So complete the square, this is how it works. You're going to take your x squared plus 6x plus 20, and you're going to say, what perfect square could I rewrite that as? So the x squared needs to go down to an x, and the 6x needs to be cut in half to just a 3 squared. So you're always cutting this one in half to put it there. Now, here's why. If I do x plus 3 squared, that would be x plus 3 times x plus 3 again. So let's multiply it out and see what we're missing. So x times x is x squared. What about x times 3? That'd be a 3x. And then another 3x, that's going to give me the 6x. But then 3 times 3 is what? 9. And remember, I didn't only have a plus 9, I had a plus how many? 20. So then what would be left over is 11. So if you think about it, this and this are the exact same thing. But essentially, I wouldn't multiply this bottom part out every time. I would just think about whatever 3 squared is, you need to remove that from whatever the constant was at the end. Okay, so let's do the next one. I have an x squared plus 10x plus 30. My x squared is going to drop to an x. What's going to happen to my 10? I'm going to cut it in half to a 5. And then I would say, wait, what's 5 squared? 25, but I really have 30. So how many are going to have to stay outside of the perfect square? 5. Okay, one more like that. X squared minus 8x will go into what? X minus, cut it in half is 4. And now I want you to think about, even if this is a minus, what's negative 4 times negative 4? Plus 16. So out of the 20, how many am I leaving behind? Plus 4. So even if that middle number is a negative, it actually really doesn't matter. It's the same thing. Okay. So here's how we can use that to use number 9. We're going to complete the square on the bottom. So I have 1 over x squared plus 4x plus 20. We're going to complete the square on this guy. What will it look like on the bottom when I complete the square? Okay, x plus 2 squared, because I have to cut the 4 in half. And then 2 squared gives me 4, which means I'm leaving 16 out. So plus 16. Okay, then I want you to reverse the order that you're adding those on the bottom. So this is really the same as 1 over 16 plus x plus 2 squared dx. And now this is an inverse tan problem. So what would my a be if a squared is a 16? A would be a 4. What would my u be if it's this stuff inside the squared? X plus 2. Then my du dx, the derivative of x plus 2, is just a 1. Which means that a du over 1 is going to replace my dx. And then I would say, okay, well then this is now 1 over my 16 is going to go to a 4 squared. My x plus 2 is now a u squared. And then technically it's a du over 1, but nobody really cares about the over 1. And now I can use my formula. So it'll be inverse tan u over a. This time my u is an x plus 2 over my a is a 4. And then what do I need to put in front? 1 over 4 plus c. All right, one more like that. Okay, look at the bottom, complete the square on it. So it's a x squared minus 10x plus 29. I'm going to rewrite that as an x minus 5 squared. Because I can only take half of the 10 when I complete the square. Then 5 squared gives me 25, which means out of the 29, I'm leaving behind how many? 4. Okay, then remember, I'm going to reverse the order on the bottom so that it's 4 plus x minus 5 squared. Okay, also, you cannot just cross those 4s out. So don't do that. All right, what's my a? A is a 2. U is an x minus 5, which means my du dx is just a 1, which means that my du over 1 will replace my dx. And then we're ready to rewrite. So it'd be integral 4 over, my 4 is turning into a 2 squared plus u squared du over 1. And then the 4 over 1 on top is going to stay a 4, and I can just kind of pull it out, and then I have my special rule. So it'll go to inverse tan. Remember, it's always u over a. So that's x minus 5 over 2 plus c. And then remember, the tan has a 1 over a in front of that. Also a 4. So 1 over a will be a half. Times it with the 4 will make it a 2. Make sense? All right. Maybe we'll do one off the homework with endpoints just so you can get something done off of that. So go ahead and if you want to do it with us, log into Ultimate. Okay. So you should be able to see it. And then we're gonna do inverse trig with complete the square. Does this one have endpoints? No, one doesn't. This one have endpoints? The very last one? Perfect. Okay. So go ahead and write it down. And then the first thing that I want you to kind of think about is it the inverse sine one or the inverse tan one? So one of the ways that you can tell which one is which is that, remember, your inverse sine needs to have a square root on the bottom and it's a minus. Your tan needs to have a plus in the bottom, no square root. So we can tell it has to be this type. So we're going to do integral 0 to 2, 6 over 4 plus x squared dx. Okay, so first thing, what are we going to pick as our a? A is just a 2. Our u is just going to be an x. Okay, because it's not like a 9x squared or something like that. Then the derivative of u would be what? Just a 1, which means it's a dx over 1 equal to du. We're going to rewrite our integral. So it's 6 over 2 squared plus u squared du over 1. And then I see, oh, I can go ahead and divide the 6 and the 1. That gives me just a regular 6. And then this is now my special 2 squared plus u squared du. What would the antiderivative be of that? And -1. U over a would be x over 2 plus c. Put the 1/2 in front, multiply with the 6. That means that really this is 3 inverse tan x over 2 plus c. Okay, now notice that we're putting it in brackets because we have endpoints. Okay, also notice we're not going to change the endpoints because we brought our antiderivative all the way back to x's. So on top, we're going to plug in a 2. On bottom, we're going to plug in a 0. So on top, I want 3 inverse tan. And then I'm plugging in a 2 here. So 2 divided by 2 is a 1. Okay, now it's a little bit trickier with the tans to do reverse, but remember, how do I get tan? I do y divided by x. So think about it on your hand. If I want x, sine and cosine to divide to 1, they have to equal each other so that they cancel out. So on your hand, which finger could I pick so that the top and the bottom fingers are the same and multiplied to 1? The middle finger, which would be pi fourths. So it'd be 3 pi fourths. So if tan is sine divided by cosine, I need it to come out to be a 1. I need middle finger. Now let's do this one. Okay, I'm going to do 3 inverse tan. I'm plugging in a 0. 0 divided by 2 is still a 0. And then I would think about what finger is gonna give me 0 for tan. Well, think about tan is sine over cosine. So do I want the top to be a 0 or the bottom to be a 0 if I want it to divide to 0? The top, because remember, it's okay is 0, no is undefined. So then I have to think about, okay, well, if I want a 0 on top, tan is sine divided by cosine, then sine has to come out to be 0, which means I want no fingers on the bottom. Then which finger do we want? The pinky, which is 0. So then it'd be 3 times 0, which is 0. And then you do this minus that. So 3 pi fourths minus 0 would be 3 pi fourths is your answer. When you type it in, you can just type in pi, P-I, and it'll pop up. So just use 3 pi and then over 4. Okay, for the last question. All right. Good job.